Gas laws. Boyles Law. I'm Mr. B. Boyle's Law is an experimental gas law that describes how the pressure of a gas tends to increase as the volume of the container decreases. The absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies if the temperature and the amount of gas remains unchanged within a closed system. Mathematically, Boyle's law can be stated as follows, where P is inversely proportional to 1 over V, or pressure is inversely proportional to the volume. We may also write P times V is equal to a constant, where P1 times V1 is equal to P2 times V2, which is equal to P3 times V3, which is equal to a constant value. This is a gas within a closed system. P denotes the pressure of the system. V denotes the volume of the gas. K is a constant value representative of the temperature and the volume of the system, and temperature is assumed to be constant when using Boyle's law. For the gas laws, this general information will always apply. Pressure is in ATM or kPa, where 1 ATM is equal to 101.3 kPa. This is all on reference table A. The temperature is in Kelvin only, where 0 degrees Celsius is equal to 273 K. This information is also found on reference table A. Converting Kelvin to Celsius, where K is equal to degrees C plus 273. This formula can be found on reference table T. Consider the following practice exercises. If a gas at 25 degrees Celsius occupies 3.60 liters at a pressure of 1 atmosphere, what will be its volume at a pressure of 2.5 atmospheres? Then we'll be asked to calculate the increase in pressure when 2.00 liters at 20 degrees Celsius is compressed to 1 liter. And finally, if the volume of a gas at 150 kPa decreases from 2.4 liters to 1.5 liters, what will be the new pressure? Let's begin with the first practice problem. If a gas at 25 degrees Celsius occupies 3.60 liters at a pressure of 1.00 atmospheres, what will be its volume at a pressure of 2.50 atmospheres? We begin by writing the formula. P1V1 is equal to P2V2. Remember, the temperature is not important in this calculation. We may rearrange the formula to write the following. P1 times V1 divided by P2 is equal to V2, where 1 atmosphere is the pressure, is P1, 3.60 liters is V1, and 2.50 atmospheres will represent P2. Inserting the information into the formula yields the following result. 1.0 atmosphere times 3.60 liters divided by 2.50 liters is equal to V2. And V2 is equal to 1.44 atmospheres. Now we're asked to calculate the increase in pressure when 2.00 liters at 1 atmosphere and 20 degrees C is compressed to 1.00 liters. Again, we begin with the formula P1V1 is equal to P2V2. And remember, temperature is not important in Boyle's Law calculations. Rearranging the formula yields the following. P1 times V1 divided by V2 is equal to P2, where this time P1 is 1 atmosphere, V1 is 2.00 liters, and V2 is equal to 1.00 liters. Inserting the information into the formula yields the following result. 1.00 atmospheres times 2.00 liters divided by 1.00 liters. Clearly, in this particular case, the liters will cancel. And P2 is equal to 2.0 atmospheres. Finally, if the volume of a gas at 150 kPa decreases from 2.4 liters to 1.5 liters, what will be the new pressure? Remember, the formula to use is P1V1 is equal to P2V2. Rearranging the formula yields the following. P1V1 over V2 is equal to P2, where P1 is 150 kPa. V1 is equal to 2.4 liters, and V2 is equal to 1.5 liters. Inserting the information into the formula yields the following. 150 kPa times 2.4 liters divided by 1.5 liters. The liters will clearly cancel out. And P2 is equal to 240 kPa. This concludes my explanation of Boyle's Law. Hopefully this video has been helpful. Thanks for watching.